Bismillahirrahmanirrahim. Assalamu alaikum students. This is Tariq, lecturer in economics. Today we will discuss about the descriptive statistics, tabular and graphical measure. Introduction of this section. In this section we will discuss about the different descriptive statistical tools like tables and graphs. As well as we will learn that how we can analyze, summarize, present and interpret the large data using tables and graphs, and how we can make the data easy to read, easy to understand, and how we can make the data meaningful with the help of these statistical tools like tables and graphs. We are starting from the first data type, qualitative data. Qualitative data, when we collect informations about any particular element of interest in names or in labels form. This data is called qualitative data. How to develop frequency distribution table for qualitative data. So, a statistician can analyze, can summarize, can interpret the large data using frequency distribution table, which is a statistical tool. How statistician can develop frequency distribution table? We are learning some basic terminologies about the developing frequency distribution table. So the first terminology, what is frequency? The number of times of a particular data item or class is called frequency of the item or class in the entire data set. What is frequency distribution? In frequency distribution, we will divide the large data into groups, into classes, and then we will count that how many times that group or class, how many times a particular class or particular group or particular data item is occurring in the entire data set. The number of times of each data item or particular data item is called frequency of the item. So this frequency distribution table is a statistical tool to summarize the data, to interpret the data, to make the data easy to read, easy to understand. I am again repeating what is frequency. Frequency means the number of times of a particular data item in the entire data set. What is frequency distribution? In the frequency distribution, we will divide the large data into groups, and then we will count that how many times each group is happening in the entire data set. The number of times of each group is called frequency, and this is the way to make the data easy to understand, to make the data meaningful, to analyze the data and to summarize the data. Another terminology, relative frequency distribution. Relative frequency distribution describes the fraction or proportion of each class relative to the entire data set are relative to the all classes. Its mean relative frequency distribution is one terminology that statistician can use to compute the proportion, the fraction of the particular data item or particular class relative to the all other classes or entire data set. Formulation: how statistician can compute RFD, relative frequency distribution. Relative frequency distribution is equal to frequency of the particular class divided by the number of total observations. With this formulation, statistician can calculate relative frequency distribution for a particular class, particular data item. Another terminology, percent frequency distribution. The percentage of each class relative to the entire data set or other classes is called percent frequency distribution. Formulation is mentioned here. Formula of percent frequency distribution, PFD, is equal to RFD multiplied by 100. It's mean that if statistician is going to compute the percent frequency distribution of a particular class, so statistician has to multiply the relative frequency distribution of the class with 100, so he will calculate the percentage of that class out of the entire data set. So these are the terminologies that statistician can use to develop frequency distribution table and summarize the data and analyze the data. Now I'm going to develop one example and develop a frequency distribution table. So I will repeat all these terminologies practically: frequency distribution, relative frequency distribution, and percent frequency distribution. For example, develop the frequency distribution table for the 15 purchases of the 5 soft drinks. The raw data is given. This is one example about the 15 purchases of the 5 different soft drinks. The data, the informations are given in raw form as given here: Pepsi, Coke, Dew, Sprite, Coke, Pepsi, Sprite, Pepsi, 7-Up, Dew, 7-Up, Pepsi, 7-Up. These are the statistics about the 15 purchases of 5 soft drinks. These names are given. The data is qualitative data because the informations are in names form. These are the names of the 5 soft drinks. So we are going to develop frequency distribution table, and this table will summarize this raw data. So this is the frequency distribution table, and I categorize in 1, 2, 3 and 4 columns. The first column represent groups of the data, are classes of the entire data, are data items. So we divide the raw data into 5 groups, into 5 classes. The first one Pepsi, second Coke, third Dew, fourth Sprite, and fifth 7-Up. So as we define in the frequency distribution that we will divide the entire data into classes, into groups. So these are the 5 groups. Now frequency distribution, or you can say frequency of each class or each data item. Here we are as we define frequency, that frequency we will count the number of times of each class or each data item in the entire data set. So I'm counting the frequency of Pepsi: 1, 2, 3, 4, 5 and 6. So Pepsi is occurring 6 times in this data set. That is why frequency of the class Pepsi is a 6 in this data set. Now Coke, again we will count the number of times of occurrence of Coke in the raw data set. So 1, 2. So Coke is happening twice, 2 times. So the frequency of the Coke is 2. Again Dew, again we will count that how many times this Dew is occurring in this entire data set. So this is 1 and 2. Again the frequency of Coke is twice, 2. Sprite, again count 1 and 2. So the frequency of this Sprite is also 2. And now the last class and its frequency, that is 3. Count from here in the last column: 7-Up, 1, 2 and 3. So 7-Up class is occurring 3 times. So this is the frequency of the class 7-Up. So when we add all these frequencies, the total number of observations, the total number of data items in the large data set are 15. So we are again repeating classes and you can say frequency. Now I'm coming toward the relative frequency distribution. As we study in the previous slide formula that relative frequency distribution described the fraction or the proportion of the particular class relative to the all classes relative to the entire data set, and we study the formulation over there that relative frequency distribution RFD is equal to frequency of the class divided by the number of total observations. So this is clear. I compute mathematically, I calculate mathematically in here relative frequency distribution RFD. Relative frequency distribution of the first class Pepsi is frequency of the class 6 divided by the total number of observations 15, so is equal to 0.40. RFD statistician can compute by dividing frequency of the class by the total number of observations. So we divide 16 is the frequency of the class and 15 the total observations, and we find the relative frequency distribution of the first class, which is 0.40. Relative frequency of the second class, so frequency 2 divided by the total observation 15, so 2 by 15 is equal to 0.1333. This is the RFD, relative frequency distribution of the second class Coke. Similarly, we can compute relative frequency distribution of the third class DIV. Frequency of the class 2 and divided by the total observation 15, 0.1333. Again, relative frequency of the fourth class Sprite. So frequency of the class divided by the total observations 2 divided by 15 is equal to 0.1333. And in the same way we can compute relative frequency distribution for 7-Up. Frequency of the class divided by the total observations in this third column. 3 is the frequency of the class 7-Up, and we are dividing by the total observation 15, so we find out 0.2. So in this way we can compute relative frequency distribution for a particular class or particular data item by dividing frequency of the class by the total number of observations. The last is 15 is the total number of observation. Now we are switching toward the percent frequency distribution PFD. So again we study on the previous slide in here percent frequency distribution PFD, the percentage of each class relative to the entire data set or relative to the all other classes, and this is the last line formula of percent frequency distribution. PFD is equal to RFD multiplied by 100. With this formulation, statistician can compute the percentage of the particular class out of the entire data set. So PFD is equal to relative frequency of the first class Pepsi, which is 0.4. 0.4 I am going to multiply with 100, so we compute 40% of the first class Pepsi. Now percent frequency distribution of the second class, multiply relative frequency distribution of the class with 100, so we calculate 13.33%. Again, percent frequency distribution of the third class DIV, we will multiply relative frequency with 100, so relative frequency of the DIV is 0.13 multiplied by 100 is equal to 13.33%. In the same way we can compute PFD, percent frequency distribution for the fourth class Sprite, multiplying relative frequency of the Sprite with 100 to calculate 13.33%, and the last one 0.2 multiplied by 100 is equal to 20%. So these are all percent frequency distribution percentages for the 5 classes. So we develop the frequency distribution table for the 15 purchases of 5 soft drinks, and now this table can interpret this data, can summarize the data, can make the data easy to read, easy to understand. And now we are coming down, note frequency distribution table, summarize the data and make the data meaningful, because in this form, in this raw form, statistician can say nothing about this data, just Pepsi, Pepsi, Coke, Dew, Sprite, Pepsi, Sprite, Coke, Pepsi. What is this? We cannot say anything. We cannot understand this data. But from this frequency distribution table, we can say, we can summarize, we can interpret these informations. Why? Because we divide into classes and we develop the frequency distribution table. Interpretation, yani what does this frequency distribution table means? What in words we can say about this frequency distribution table? So Pepsi is the leading soft drink, people like it. 0.4 are 40% customers purchase Pepsi. Our 40% sale is of Pepsi out of the 100% sale. So it's mean that from the first class Pepsi, we can say that 0.4 are 40% of the total sale, that is of Pepsi, and Pepsi is the most attractive soft drink, people like it, and Pepsi company capture the major shares of the market. 7-Up is the second attractive soft drink. 20% sale is of 7-Up, so this is the second attractive soft drink, and this is the second company which cover the major portion of the market. And similarly, Coke, Dew and Sprite are on the third position. They are individually capturing 13.33% market shares. So this is interpretation of the frequency distribution table, that from the frequency distribution table we can analyze, we can summarize the given data set. As I am again repeating here, suppose from this frequency we can summarize as 6 is the large number, the big number. So this is very clear that actually sale of Pepsi is more relative to all other soft drinks. So it's mean this is the attractive soft drinks, we can say. And the second one, 3, is more than all other 3 soft drinks, Coke, Dew and Sprite, and their sale. So this is the second position soft drink in the market. So it's mean with the help of frequency distribution table, statistician can summarize, can analyze the data. We can say about the percentage sale of each company, each class. We can say about the percentage sale relative to the other classes of the using this frequency distribution table. Now we are switching toward the to be continued bar graph. It's mean we develop the frequency distribution table. Tabular form is one statistical tool to summarize the data, to make the data easy to read, easy to understand, to make the data meaningful. But other than frequency distribution table, we have another tool which is graph, and for the qualitative data we will use bar graph or bar chart. So bar graph is a statistical tool to analyze, summarize, present, interpret and make the data meaningful, which is easy to read, easy to understand. Plot the classes, the groups on the horizontal axis and frequencies on the vertical axis. Bar is extended to the corresponding frequency as shown in the bar graphs on the next slide. So in this slide we are going to discuss about the second descriptive statistical tool, which is graph. Graph is also one statistical tool that statistician can use to summarize the data, to interpret the data, to make the data meaningful. And in here I give the description of bar chart or bar graph. What is the description? That in the bar graph we will plot the classes, the groups, the data items on the horizontal axis, and we will plot mean we will show frequencies of each class or frequencies of each data item on the vertical axis. Then we will extend bar to the corresponding frequency, and this graph will tell us about the 15 purchases of 5 soft drinks. So I am switching toward the bar graph. This is bar graph for the frequency distribution, and in the first bar graph, this one, this is for frequency distribution. In the frequency distribution table we have frequency distribution, we have relative frequency distribution, we have percent frequency distribution. This bar graph is this is clear on the screen. This bar graph is for frequency distribution only. And as I told you in the previous slide, that we will plot the classes, the groups, the data items on the horizontal axis like Pepsi, Coke, Div, Sprite and 7-Up. And we will plot the frequencies on the vertical axis. So 1, 2, 3, 4, 5, 6, 7. These are frequencies on the vertical axis. Now, how we can interpret this bar graph, as this is clear bar graph for the 5 soft drinks, 15 purchases, frequency distribution. Bar chart is another statistical tool to summarize and interpret the data and make the data easy to read, easy to understand. So interpretation, where 6 is the largest frequency and orange bar is extended to the frequency distribution 6, it shows that people like Pepsi. That is why Pepsi sale is more as compared to the other soft drinks. 7-Up represented by blue bar is the second lengthy bar, which is extended to the frequency distribution 3, so its sale is more than Coke, Sprite and Div, as well as Sprite, Coke and Div are on third position. So from this bar graph or from this bar chart, the first orange bar, which is extended from this 0 to this frequency 6, this tells us that this is the largest frequency and this is the largest bar, and it shows that people like Pepsi and the sale of Pepsi is more relative to the all other soft drinks. The next blue bar you can see from here, 7-Up, this is extended to 3, the second largest bar, and it covers the major portion of the market, which is 7-Up, and the all other 3 capture the equal portions of the market, Coke, Div and Sprite. So from this graph, statistician also can summarize the data, can understand that large bar represent major portion of the market and small bar represent lower portion of the market. So statistician can say that this particular soft drink is more attractive and this particular soft drink is less attractive. So this is all about the descriptive statistical tools, tables and graphs to summarize, to analyze, to present and to interpret the data, to make the data easy to read, easy to understand, and how to make the data meaningful using tables and graphs.